Good afternoon, class. Today we are starting a new unit called Natural Disasters. What do you guys think natural disasters are? Very good. They are events that occur in nature, could be due to stress on the earth or weather conditions or atmosphere. What are some natural disasters that you guys already know about? Very good. Tornadoes, hurricanes. Anybody else? Tsunamis, that's right. Tsunamis actually lead us into what we're going to focus on first in this unit, which is going to be earthquakes. And earthquakes cause tsunamis. They're earthquakes that happen underneath the ocean at the sea floor. And they happen and cause the waves to buckle and create a huge tsunami wave that crashes onto land. And that can do a lot of damage. What are some things you guys want to know more about? More specifically earthquakes, but you guys can also write down some things or say some things about other natural disasters because we'll get to those later as well. Okay, so how they occur, what causes them? You know that they do a lot of damage. Okay, yeah. So how do they do all that damage? What makes them so powerful? Got it. Okay, so what we're going to do, I'm going to pass out a KQRN, which is kind of like a want to know, learned type chart that you guys are going to fill out. And I want you guys to take a few minutes just to fill out all the things that you already know about natural disasters, more specifically, again, earthquakes, because that's what we're going to be working on the most right now. And then when you guys are done with that, I want you to pull out your tablets, and I want you to go onto our Google Classroom and select the link that I've posted. We've got this from Weather Kids, and I want you to go through and read that. If you guys get done ahead of time, and we will go over it as an entire class here in a little bit, but I want you to be paying attention to some key vocabulary that we're going to be learning. So earthquakes, obviously, because those are what our unit is mostly about. Tectonic plates and how they're involved, aftershocks and tremors, and then I want you to be looking out for Richter scale. You guys might already know that the Richter scale is how we measure earthquakes, but how exactly do they do that, and what are the different levels that it measures? Alright? I'll give you guys just a minute to finish that up. Alright, just to cover some of this stuff. So what is an earthquake? Earthquakes are the shaking, rolling, or sudden shock of the Earth's surface. They are the Earth's natural means of releasing stress. More than 1 million earthquakes rattle the world each year. The West Coast is the most at risk of having an earthquake. But earthquakes can happen in the Midwest. Along the East Coast, earthquakes can be felt over large areas, although they usually last less than 1 minute. Earthquakes cannot be predicted, although scientists are working on it. So what causes an earthquake? There are about 20 plates along the surface of the Earth. Those are the tectonic plates I was talking about, that move continuously and slowly past each other. When the plates squeeze and stretch, the huge rocks form at their edges, and the rocks shift with great force, causing an earthquake. Think of it this way. Imagine holding a pencil horizontally. If you were to apply a force on both ends of the pencil by pushing down on them, you would see the pencil bend. After enough force was applied, the pencil would break in the middle, releasing the stress you have put on it. The Earth's crust acts in the same way. As the plates move, they put force on themselves and each other. When the force is large enough, the crust is forced to break. When the break occurs, the stress is released as energy, which moves through the Earth in the form of waves, which we feel and call an earthquake. So what are those tectonic plates? The theory of plate tectonics is an interesting story of continents drifting from place to place, breaking apart. colliding and grinding against each other. The plate tectonic theory is supported by a wide range of evidence that considers the Earth's crust and upper mantle to be composed of several large, thin, relatively rigid plates that move relative to one another. And then in this graphic above, these are kind of what some of them are shaped like, these outlines here. The plates are all moving in different directions and at different speeds. Sometimes the plates crash together, pull apart, or sideswipe each other. When this happens, it commonly results in earthquakes. Okay, so now we're going to watch a short little video here.
From above, the planet appears eerily still. But every mountain range and every chasm on its face is a scar, with many telling a story of when the Earth rumbled to life. Earthquakes occur around the world. They've been recorded on all 7 continents, but most quakes take place in just 3 regions. The Mid-Atlantic Ridge, an underwater line that runs down the Atlantic Ocean, the Alpine Belt, which stretches from the Mediterranean to Southeast Asia, and the Circum-Pacific Belt, which traces along the edges of the Pacific Ocean and is where about 80% of all earthquakes occur. These areas experience the most earthquakes due to what lies beneath the surface. Earthquakes are the result of pressure, specifically pressure caused by extreme stress in the Earth's crust. That stress can be caused by volcanic activity or even man-made activities in certain areas. However, most earthquake-inducing stress is caused by the movement of tectonic plates. Tectonic plates are constantly moving, either against, away, along, or underneath each other. But sometimes their edges may catch and stick. The plates, however, continue to move, or at least attempt to. Energy from this attempted movement builds around the edge's sticking point, creating immense pressure until the edges are forced to let go and the plates slip. This causes a sudden and powerful release of energy, so powerful that it breaks the Earth's crust. This fracturing emits shock waves through the ground and causes intense vibrations, or quakes. In fact,
so we will finish this video here in a little bit, but what I want you guys to be thinking about is what we are going to be doing. So for this activity that we're going to do after the end of this video is you are each going to be assigned at your tables a earthquake that has happened in history, some more recent than others, and I want you guys to pay attention to the strength and where it became like the epicenter, which is like where it started, and how far out it affected and what kind of damages it did, and be thinking about the kind of materials of the buildings and the locations where these earthquakes took place. Alright? And then we're going to fill out and answer some questions and share them with the class at the end. Alright, so I'll give you guys a few minutes to finish the video, and then I want to get started on your research. So you'll still need your iPads out for that, and we will get started.
the world's most earthquake-prone regions are where the most geologically active plates